Hi everyone, this video is posted on the request of our subscriber Vidya Ammu. She has asked around 4 questions. Now I answer her first question regarding smart irrigation system. I'll try to answer her other questions in the forthcoming videos. Here we try to construct the simplest and smart irrigation system using TinkerCAD. Get into TinkerCAD login as usual and click circuits. Here click create new circuit. This is your workspace. First we'll change the title, give it as simple and smart irrigation system. The main components needed for the system would be a small breadboard, Arduino board, a DC motor which will act as a water pump, then a temperature sensor. Here this will act as the soil moisture sensor. Along with this, you can choose a H-bridge motor driver. This is L293D IC. It is the most commonly used driver for bidirectional motor driving applications. This IC can control 2 DC motors. Further, this IC can drive small as well as quite big motors. That is why we use this IC here. We can also construct the circuit without this IC. The only difference would be the DC motor will run very slowly because the supply which is available from the Arduino board will not be enough to run the DC motor. That is why we use this H-bridge motor driver which will help you to drive the DC motor in a better way. Now we'll get into the connections. We'll give the basic connections first. Connect the ground to the negative of the breadboard. Put it in black. Next, connect 5 volt supply to the positive of the breadboard. Put it in red color. Next, connect this ground to the other edge. Put it in black. Next, connect this positive to the other positive of the breadboard. Put it in red color. We do this to make the connections in a simpler way. Next, coming to the temperature sensor connections, this is the power pin. So connect this to the positive of the breadboard, put it in red. This is the ground pin. So connect this ground pin to the negative of the breadboard, put it in black. This is the Vout pin. So we take this pin and we connect it with the analog pin. We can connect it with any of the analog pin. So I connect it to A1. Next, coming into the DC motor, we can connect these two terminals 1 and 2 directly to the Arduino board. But as we have told earlier, when we connect it directly with the Arduino board, the supply given from the Arduino board will not be enough to run this DC motor. If you connect it directly, this DC motor will run in a very slow way. So what we do, we use this H-bridge motor driver which will help you to run this DC motor in a better way. So coming into this connections, this is the power pin. Connect this to the positive of the breadboard. Put it in red. Next, this is enable pin. Connect this also to the positive of the breadboard. Put it in red. Similarly on the other side, this is enable pin. Connect it to the supply. Put it in red. This is power pin connected to the supply. Put it in red. These two are the ground connections. So connect this to the ground. Put it in black. Connect this to ground. Put it in black. Similarly here these two are the ground pins. Connect these two to ground. Now you can see here there is one input, one output. The second output, second input. Third input, third output. Fourth input, fourth output. So you can see here that you can connect 2 DC motors. So each of this terminals of the DC motor can be connected to the 2 input pins. The other 2 pins can be connected to other DC motors. Totally you can connect 2 DC motors here. But as we have only one DC motor, we'll connect with any of the 2 inputs available. The other 2 input and output can be left freely. This is the input pin. So this input pin is connected to D10. It is the digital PWM pin. Give it in a different color. From this is the output pin. So this output pin is connected to the negative terminal of the DC motor. Give this also in the same color. Next, This is another input. So take this input and connect it to the another digital PWM pin. Put it in any other color. I give it in purple. From here, the output is connected to the other terminal of the DC motor. I put this also in purple color. So two inputs are connected to Arduino board, which is in turn connected to the DC motor. Now I think all the connections are over. Now we can give the annotations. So this DC motor acts as water pump. So name it as water pump. This temperature sensor acts as moisture sensor. So this gives you details about the soil moisture. Next we'll get into the coding part. We can delete this. First thing we need to do here is create variable. Temperature value. First we need to set this temperature value. We need to set this temperature value to read this A1 pin because the temperature Vout is connected to A1 pin. So get into input. So read temperature on pin A0. So here it is A0. We have connected it to A1. So change it to A1. Now the temperature value will read the value from this A1 pin, which is the analog input pin. Next, we try to print this to the serial monitor. So the serial monitor should read this temperature value. So we put it like this. Next, we choose control. So we choose an if condition. And to formulate it, we take this mathematical formulations. Take this temperature value. Here, if the temperature value is less than, say we put it as 30 degree. So what we are trying to say here is, if the soil moisture is less than 30, that is if the soil has good moisture, then what shall we do? Get into output, set the pin numbers connected to the motor. That is two pins are connected, 10th pin and 5th pin. So 10th pin and 5th pin. So both is set to be high. Next, you choose another condition. If you can also go for else condition, it is up to you to do it. Choose the mathematical formulation. Again set the temperature value. Now if the temperature value is greater than, set it to be 45. Now if the temperature value is greater than 45, that is the temperature is high, or if you see that there is less moisture in the soil, then again we set the two pins of the DC motor to run. So pin number 10 and pin number 5. Set the negative terminal. The 10th pin is connected to the negative terminal and the 5th pin is connected to the positive terminal. So set this to low and set this to high. You can also set it the other way. What will happen is the DC motor will run in anti-clockwise direction. That will be the only difference. I think the coding part is over. So here, first the temperature value will read it from the analog pin A1. You can see that on the serial monitor. Now if the temperature is less than 30 degree, then the DC motor will be in off state. That is, the water pump will be off. If the temperature is greater than 45, then this DC motor will on. That is, the water pump will be on in order to pour water to the plant. That is, in order to irrigate the land. That is the condition. Now we'll see how it works. Let us start the simulation. So let's check here. Get into the coding part. See the serial monitor. So 24 degree. So the temperature is somewhere below 24 degree. So the DC motor is not on. Right? So when the temperature is below 30, that is when the soil has enough moisture, the water pump is in off state. Now when the temperature increases above 45, see the temperature is 73 here in the serial monitor. So when the temperature crosses 45 degree, what happens? The DC motor is on. That is, the water pump is on so that the land will be irrigated. This is how the smart irrigation system works. So check here. See in the serial monitor, when the temperature is below 30 degree, the DC motor is in off state. The water pump is off. When the temperature moves above 45 degree, then the DC motor is on. That is, the water pump is on in order to irrigate the land. So this is the working of a smart irrigation system. You can also construct this circuit without this L293D IC, that is without this H-bridge motor driver. Instead of this, you can use a NPN transistor, or you can use a 12 volt supply or a 9 volt supply regulated to 5 volts and then use it. Any way you can construct this circuit. But I feel this is the simplest and easiest way of constructing an irrigation system. So try this circuit and let me know how it works. Thank you for watching this video. If you find this video to be useful, kindly subscribe it and share it with your friends. To get immediately notified whenever I upload a video, kindly click on the bell icon.